Today's topic is home routers. And home routers are a box that is in your home. It's a technology device. We're going to talk about what a home network is and some features of routers and some improvements. Now, obviously, the biggest advantage of having any kind of a network is that it replaces the ability or the need to use physical media. You don't have to use a floppy disk or a flash drive to move things like a document you might want to send to a printer or something you want to email as an attachment to somebody. So all of these things can be done without physical media these days. And we really don't keep a lot of physical media around. We keep most everything on our computers, and we don't use portable physical media that much anymore. This is a picture of a router. Some have no antennas, some have two, some have three, so they vary in how they look. But one of the router's main functions as your home is to create this Wi-Fi signal. And if you go to a coffee shop, they've got a router that creates a Wi-Fi signal. If you go to a hotel, they've got a router that creates a Wi-Fi signal. So the router sometimes can be referred to as a hotspot, but not usually. But sometimes you might see that. One of its main functions in life is to assign IP addresses to devices. And I'm going to explain what IP addresses are a little bit more. And it routes data. That's how it got the name router. It's a traffic cop that sends messages from one place to another and directs traffic like an intersection. So at your home, you've got a local network. And one of the main uses of a local network might be sharing a network printer. I just hooked up a new printer today on my network, or sharing files between computers or devices on your network. So typical home devices include a computer, laptop, smartphone, printer. There's lots and lots more, but let's just talk about these four. And then when we go through Wi-Fi advancements, you'll see what's happened to make it possible to do a lot of other things. So one of the things the router does, it creates something called a Wi-Fi signal. And when you look up on, this is a screenshot from my iPhone, you can see I've got Wi-Fi turned on. This is the Wi-Fi settings, and I can see my various networks. Let's see what's going on. There we go. My mouse is moving a little bit too fast then. And I can see Bobology 5G here. That's my local area network. That's the name of my network. Okay. But I can see others here too. I mean, I'm on Spectrum Mobile. I have a hotspot here. I also have guest, and then I see Helen down here. That's one of my neighbors. I can pick up her Wi-Fi signal. So these are all SSIDs for networks. Some of them are yours. Some of them might belong to someone else. And if you see a little lock on this symbol right here, that means that it needs a password. So you have to know where the network is. That can be found when it's broadcasting. And this router antenna, that's one of the things it does. It broadcasts and receives information. So that's what SSID means if you ever hear that term. It's the name of your network. Now, in your local area network, you can connect local devices. Your router helps connect the devices together. So if you connect a computer to your router and a laptop to your router, they're both on the network. You might need software that helps you share files or printers or storage drives. But this type of home network is what basically gets created inside your home. We're going to talk about this a little bit more. Rarely is it used without an internet connection. But your internet service provider is what that makes possible. You don't need an internet service provider to actually have a local area network. You can use a router and connect devices to it without a router. Now, one of the things we understand is cables, and this is an example of a printer. That's a very common reason for having a device with a local area network is you want to print from wherever you are, from multiple devices. But this printer is attached to a computer with a USB type cable. A very common way to do things, very reliable, very dependable. But it's only able to communicate with this printer because it has a physical connection between the printer and the computer. That's the only device that sees. But the computer can see the printer, but the only thing the printer sees is the computer it's connected to by cable. It's reliable, but it doesn't let you print from multiple devices. And these days we have desktops, we have laptops, we have smartphones. And if your printer is connected with Wi-Fi through your router, then other devices can see your printer and they can print to it. So that's an example of how a local network works and how devices can see each other and communicate with each other. And your router's the traffic cop. You have a printer, you have a Word document open, say on your laptop, and you want to print it. Your laptop can see the printer, add it as a network printer, and then direct documents to print out here. Your desktop can add a printer through its print software, and it can print out. So you have the ability to take advantage of more communications between devices. It's theoretically possible if your printer has a scanning tool built into it, many of them do, you can actually scan documents from your printer to your computer, but that requires your printer and software on your computer to use the scanning function. But it's possible to go both ways, and your printer has to tell you, hey, the job's done printing. Okay, so it has to communicate with your computer. Now, there's these things called Internet Protocol addresses, and they are unique numbers. They're assigned to every device on the internet, and they're like a mailing address. So if you want to get a letter from you to me or me to you, you have to write an address on the envelope, and then the Postal Service knows how to route it and deliver it. In that case, the Postal Service is the router, but we're going to use an electronic device called a router, and it uses numbers, and every device on the internet gets assigned an IP address, including websites like google.com or microsoft.com or mybobology.com. They're all assigned IP addresses that make it possible to route the traffic, and routers are devices that know where to forward messages to and where to get them when they come back. So your router decides to assign addresses to your devices in your home. It's assigning what's called private IP addresses that are not visible on the internet. Your router has a table inside of it that translates addresses because your ISP gives your router an IP address as well that's public. So your router can be seen on the internet and the internet can see your router, but the internet can't see these devices. And your router actually keeps track of if your if your computer sends something out to the internet, it says, oh, this is coming from the IP address I gave to my home computer. If this laptop sends something out, your router is saying, oh, this is being sent from my home laptop. And it assigns these IP addresses to all of your devices so that it can send the traffic back like a web page or a streaming application back to your devices. But that's one of the functions that takes place when you connect to a Wi-Fi network through your app or device. You're getting assigned an IP address by your router, and it keeps track of that for you and lets messages go back and forth automatically. Now, so your printer, your computer, your laptop, and the router basically uses this information to route the data. So it knows, oh, you want to communicate to the printer, that's .3. These are sample IP addresses. And it wants to let you know that your laptop, okay, the print job's done. or your computer wants to send something to your printer, it knows that it's coming from dot one and it's going to dot three. And that's the purpose of a router, is to redirect all of this traffic across your home network. And there are many routers out on the internet, but this is what our home network looks like. Now, what an ISP does is an ISP connects you to the internet. So in order to get from your home out to the internet, you have to have a service with an ISP, and they will give your router what is called a public IP address that can be seen on the internet, but is not seen, but these IP addresses are hidden. And your router just translates them. It's like translating from French to German. It translates, the French IP address to the German IP address, and it gets it to the right device. So routers are really doing a lot of things for us on an ongoing basis. Now, what I want to explain to you is how this thing called Wi-Fi, most of us don't use Ethernet cables to plug in our devices anymore. Most of us use Wi-Fi, and a lot of people don't even know what Ethernet is because we use Wi-Fi so commonly. It's very, very reliable, and it's gotten faster and better. And there's an organization called the IEEE that actually manages the Wi-Fi standard for all the computing industry. So when you hear Fred talk a little bit about earlier about Wi-Fi 6E, that Wi-Fi 6E is a specification of technology that's created by the IEEE. And so the IEEE is a standards organization that is a nonprofit that advances technology, and they come out with standards that are available for anyone to use, and they can get specifications on it. So companies, if they say something is built to this Wi-Fi standard, it works across all devices. And that's one of the great things about technology, is that when you have something built to a standard, it really, really works. Now, there have been improvements with Wi-Fi, with Wi-Fi 6 being the current, and there are letters like 6E, and it starts out with 6, 6A, B, C, D, E, and then eventually they might go to 7. But Wi-Fi 6 is our current standard. It's been around since about 2018, 2019. It's faster. It can go up to 9.6 gigabits per second, which is really faster than any internet connection you can get from an internet service provider. It's more secure. It uses something called WPA3, which stands for Wi-Fi Protected Access. That's the security between your device and the router over Wi-Fi, so nobody can intercept things. And it allows us to connect more devices and mesh networks. And it introduced dual frequencies over time. So Wi-Fi is always making improvements so that we can use technology even more. So let's give a little history of Wi-Fi. Okay, so Wi-Fi was introduced at 1997. There's a number that the IEEE gives this specification. It's called 802.11. It's because it's easier to find things. Think of it like a decimal system for keeping track of documents. It was the first standard, and it could go up to a whopping 2 megabits per second. And it had a security standard called WEP, which is not used anymore. In 99, it introduced Wi-Fi 2. It increased the speed, and it improved the range of the signal. You gotta remember, you're dealing with an antenna that broadcasts a signal out from it, and it only has so much range because it only has so much power that the router has. They also introduced Wi-Fi 3 very shortly after that, which introduced this 5 gigahertz band. I'm going to explain that a little bit more. And it gave it a fast speed of 54 megabits per second. So the original standard used something called 2.4 gigahertz. It's a frequency, like a radio station has a frequency. And when you turn the dial on the tuner, you're tuning into 101.4, or you're tuning into 110 or 103.6. That's a frequency that's being used by the radio station. And Wi-Fi has two frequencies that it now uses, but before 1999 and Wi-Fi 3, it only used 2.4 gigahertz. In 2003, they introduced Wi-Fi 4. It increased the speed of the 2.4 gigahertz frequency to the same as the 5 gigahertz, okay, which was a big improvement because a lot of people still could only use 2.4 gigahertz. And it introduced this new type of encryption and security called Wi-Fi protected access. Then in 2009, we got Wi-Fi 5, which gave us even faster speeds, up to 3.5 gigabits per second. And this is when you started to see multiple antennas coming out on routers. And they could use multiple antennas to communicate to more than one device at a time. So one antenna could talk to your laptop, for example, and another antenna could talk to your smartphone on Wi-Fi. So you actually had this capability, which started to increase the capacity that Wi-Fi handled. And then in 2014, Wi-Fi 6 was first introduced. It increased the speed to what's called now 9.6 gigabits per second, and it improved efficiency even more with duplexing, which allows messages to go back and forth with multiple antennas. And it increased the number of devices that your router could communicate with at the same time, because it just doesn't talk to one person. It's like having a group discussion, and if you only had one person who could speak at a time, it would take a while for like 10 people to say something in the whole group. But if you could have 10 people talking at the same time, you could have a lot more communication going on. And that's essentially what this multiple antenna communication does. It gives devices the ability to communicate with the router at the same time. And it introduced what's called the Wi-Fi Protected Access 3 standard. I have a little typo there for it says WAP, but it should be WPA3. So what happened with frequencies? The original frequency was 2.4 gigahertz. And so your smartphone, your laptop, your printers, everything, they only needed to communicate on one frequency. In order for two devices to communicate, they have to have antennas that work the same way. So your printer and your router would need 2.4 gigahertz. And when that was the original one, it wasn't a problem. It has a little bit longer range than the 5 gigahertz, but it's subject to interference. Like microwave ovens have a frequency that's really, really close to 2.4 gigahertz. And there's a lot of other wireless devices sometimes that use them, like the old type of wireless handset phones that where you had them on a base and you'd pick it up. So there's a lot more things that use that 2.4 gigahertz. So there's a little more interference. That's one of the reasons why 5 gigahertz was introduced. It has faster speeds, but shorter range. So you might see when you get onto your Wi-Fi network and you're looking to connect to Wi-Fi, you might see something called, your router with 2 gig, or your router with 5. It's the same network, it's just a different frequency. And if you can get a strong enough signal with 5 gigahertz, connect with 5 gigahertz, it's going to be a little bit faster all the time. Now, Wi-Fi improvements have given you the ability to connect more devices. As I mentioned, Wi-Fi 4 could only communicate one device at a time. Wi-Fi 5 could do dozens, but as many of you know, we're putting a lot more devices in our homes, like the Internet of Things and home assistants. And so Wi-Fi 6 has the capability to really deal with hundreds of connections at a time, and it's going to support almost any type of home environment you might run into. So those are another improvement that's taken place with Wi-Fi. And the security function on Wi-Fi Protected Access 3, it has version 1, version 2, version 3. It's improved. Wi-Fi Protected Access 3 has what's called stronger encryption, meaning the signal from your smartphone, for example, to your router is encrypted. with really strong encryption that's virtually impossible to break or intercept. At one time, people, security and hackers, they try and intercept Wi-Fi signals, but Wi-Fi security has really improved. So Wi-Fi WPA3 is really strong. And it's been around since 2018 as in pretty much all devices. It was introduced a little bit earlier, but most routers since 2018 have it. And in Wi-Fi 6 capable routers, the WPA3 is the default security setting. So you're getting the best protection automatically. And all of our smartphones and wireless Wi-Fi devices and things like that communicate with WPA3 now. This is a photo I took this morning of the back of my router. This is a router that I use for just demonstration purposes. So over here on the left, this is a TP-Link brand router. This is the model number. It has a serial number. It has a wireless password printed on the back. So you have to have physical access to log into the wireless password. And it has an SSID. That's the name of the network. So if you're looking to connect to this router on your smartphone, you'd look for that. One of the important things I wanted to point out here is that when routers ship, this is a router purchased at a store. It's possible to go to a website and find this router's administrative functions, meaning you can change the password, you can change the SSID. When you go into settings of any device, it gives you the ability to change things. So the username that was printed on the router and the password is called admin. That means that anybody that knows admin can get access to this router, as long as they're within proximity of getting a signal for it. And so it makes it important when you actually are working with routers. If you purchase a router, make sure you change the username and password, especially the password, because that makes it more secure. Now, you might have a router, most people do, supplied by an internet service provider. So with a router supplied by an internet service provider, they're going to give you a username and a password that they created when they ship you the router. And they'll put a little sticker on the router for that will have its own username and password. But just keep in mind that an ISP supplied router, they're going to give you a username and password. But if you purchase a router, it's not set to anything unique, and you want to go in and set that differently. And the router setup instructions for most routers now, they use apps that give you the ability to set them up. They walk you through it pretty quickly. But just if you ever are changing your router out in any way, keep in mind that that admin function is not as secure as you might want it to be. So just a little wrap up is that your local area network, your router gives you this ability to transfer data. It's creating your home network, this Wi-Fi signal from the antennas in your router. And even if you don't see a physical antenna, there's one inside of it. It gives you this ability to really create your home network and be able to use it. And your internet service provider gives you the ability to take care of getting out to the internet for you. And it's really nice. It happens so fast and so quickly that we really don't have to do a whole lot of work at it. And we're all getting more and more comfortable connecting up to Wi-Fi, not just at home, but in other places as well. So that wraps things up. Bye-bye, everybody.